Okay, so this is an introduction to a piece of software called PyMOL, and it is a basically it's a molecular visualization program. There are a bunch of other molecular visualization programs such as Chimera and VMD and QtMol, and they're all basically geared towards looking at biomolecules in different ways. And it's a good idea to get to know how to use one of these particular pieces of software, and it kind of doesn't really matter which one you know how to use, so long as you know how to use one of them quite well. And of course we use these to look at proteins, nucleic acids and small molecules in 3 dimensions. A quick bit of housekeeping for PyMOL. There are a bunch of different PyMOLs. There's PyMOL 1 point something, which was the old PyMOL, and that was ran in Python 2. And there's an open source version which you can download on a Linux or on a Mac quite easily. And then there's the incentive version, which is PyMOL, the newer PyMOL, PyMOL 2 point whatever, 2.4 I think is the current version, and that's written in Python 3. And I'd advise that if you haven't downloaded PyMOL 2, that you go ahead and download that. The university has a license for it, so you should be able to get that fully activated with all of the features in it. The main file type for PyMOL are these things called PDB files, which hopefully some of you have come across. Some of you may not have. The PDB file is currently being replaced with something called a CIF file, which we don't really need to go into too much. But there are a bunch of other different file types which also open with PyMOL. One of them is the PSE file. So this is a PyMOL session file, which we'll talk about at some point, I'm sure. And then there's also .pml files and .py files, which are scripts that run within PyMOL, and Python scripts which can also run within PyMOL. PyMOL is available for Windows, for Mac and for Linux. If you're working on a Mac and you want to use PyMOL effectively, I'd advise that you buy a 3-button mouse rather than the Magic Mouse, and rather than using a trackpad, because you will find that all things are easier if you have a 3-button mouse. So I'd make a purchase of that otherwise. There are some, there's a whole ton of resources available to help your use with PyMOL. For example, there is a wiki page, and you can go through a whole bunch of tutorials here. You can look at a list of commands. For example, if we go into here, you can see that there's a whole bunch of different commands that you can use in PyMOL, and you can just work your way through this. There's also a script library where people have deposited scripts for various different things that they want to do. So have a little look through that. Let's just see. And then also this second link here in the resources. This is a nice little quick reference for you, so you can download this and print it off, and you can go through a bunch of the things in here. And effectively what we'll be doing is going through a bunch of the commands that are in here, and well, I guess this first session we'll really be looking at how to use the GUI. So a good question at the very beginning. Obviously some of you are intermediate users here and you know what a PDB file is, but we may have some people with us that don't know what a PDB file is, or what it looks like. You can go to here and find the protein data bank, and from here you can search for any particular protein of your choice. Cholera toxin B subunit, and there we are, a whole bunch of these different structures here, and they all have these 4-character PDB codes, and some descriptions, and you can go and download the files here. And when you're downloading the file, well, that was a bad example. You want to be downloading the PDB file or the here we are, the PDB format here, or the CIF format. What is a PDB file? Well, let's have a quick look at a PDB file. Is kind of a little bit important. So PDB files are just text files, and they start at the beginning with a bunch of different headers here, and next to each of the headers there are information about what's contained within the PDB file, the authors, all sorts of business like that. There's then a whole bunch of other stuff at the top of the file, which gives you basic information, and then you kind of get into the main content of the file, which are these atom lines. Now these atom lines have some identifiers here. So this is atom number 1. It's a nitrogen. It belongs to a methionine. That methionine belongs to chain A. This is residue number 1 here, and then we have the 3-dimensional coordinates. This is the x, y, z of that atom in space, and then we have here an occupancy value, which I won't go into, and we also have a temperature factor, which is a measurement of its disorder, I guess, in space. And then we just have a big list of these. This is the majority of the PDB file is all of these things. And then also we find that we have a lot of waters inside our structure here, and then it's got a few bits at the end as well. But essentially, what it really is a list of the coordinates of the atoms in space. You also can get this CIF file, which is the one that's replacing the PDBs, and again you get information at the beginning, and then you get a bunch of information here, which include the coordinates, the residue name, chain identifier, etc. So essentially what we're looking at here are just coordinates in space. So this is PyMOL here that I have open already. You can either open it by double clicking on a PDB, or you can just open it natively like I've done here. And the first thing that we want to do is to have a structure. Now, as I say, you can double click on the PDB, or you can use these commands. So I talked before about these 3 character identifiers that we have from the PDB. And what we can do is we can use a keyword here called fetch, this command, and we can fetch just straight from the protein database our PDB of interest. And here we are. Now, I should also very, very quickly actually talk about the different ways of generating these structures. There are 3 main ways in which you can get a 3-dimensional structure, and that's by using the main historical way of doing it is with X-ray crystallography. Then we can also use 3-dimensional NMR to do it, and these days now there's a lot of cryo-electron microscopy structures as well. There are different caveats with each of those which you need to think about. For example, all of them really give you an average of those atoms in space across a number of different molecules, so you have to think that these aren't going to be the exact atomic coordinates here are averages of those atoms in space, not specific specific locations, unless you look at NMR, but then that's still kind of averaged as well. But of course NMR can give you multiple solutions to your structure. The majority, as I say, come from X-ray crystallography. With X-ray crystallography there are crystal contacts which occur in order to generate your repeated lattice unit, and that can mean that some of the atoms are in places that they would not normally be if the protein was just in solution. So you have to bear in mind that there are little caveats such as that. So here we are, we're in PyMOL. I'm using my 3-button mouse. If we left click and drag, we can rotate. our molecule around. If you have it in a nice position and you want to keep your z-axis, which is our looking straight down the middle of the protein, and we left click and drag on the right hand side or on the top side, or basically just one of the sides, you can see that now while I'm rotating here, I'm actually rotating around the axis that I'm looking down. That can be useful sometimes when you're orienting yourself. If I middle click and drag, I'm translating. And if I right click and drag, I'm zooming in and out. So these are our basic ways of navigating. Left click to rotate, middle click to translate, and right click to zoom in and out. We can left click on something and we can make a selection. It has this little pink box around it when you make a selection. And the selection that we make is based down here, where you can see it says residues. So if I click on a bit of the protein here, you can see that there's a number of atoms which have been selected, and that's because I have here residues selected. If I click on the word residues, I can cycle between a bunch of different things. So it starts at atoms. So if I click on an atom here, and to remove a selection, just click in blank space somewhere. So I can click on an atom. I can click on a residue, and that's got a bunch of atoms there. I can click on a chain. That now selects my whole chain. I can click on a segment, which we don't necessarily need to go into, but here it's the same as a chain. And then the object is the whole thing that I've got selected here. So that's how we can select various different things. You can see down here we've got this little matrix here of left click, middle click, right click, and of course the wheel. I haven't talked about the wheel yet. So if I just use the wheel as standard, what I'm doing is I'm reducing the clipping plane that I'm looking at. Now this is more important when we want to look at something specific here, and we want to get rid of all of the stuff that's in the background. We can use the mouse wheel here if we're only really interested in looking at this oligosaccharide here. We can use the mouse wheel to remove some of the background rubbish, like that. But as I say, this matrix here gives you left click, middle click, right click, and the wheel, and then tells you what happens. So we can rotate, we can move, and we can move the Z plane, and we can use the slab. They're the four things that I've just talked about. What we can also do is we can modify these selections by using Shift, Control, Control Shift, using single clicks and double clicks. Now that's a lot of different variations of things you can look at. So I'll just go through. I'll leave you to play around yourself with all of these different combinations, because there are quite a lot. But importantly, I've talked about clicking and dragging. So single clicking with the left, as I say, that gives you your selection based on what we have down here. If you middle click anywhere, it centers your view around the thing that you've middle clicked on. Now this is actually probably one of the most important features here, because it allows you to navigate around your protein quite easily. Another nice one is the box feature. So if I hold down Shift and I'm on residues here, so if I hold down Shift around here, I can select, say, all the residues in this alpha helix quite easily, which might be useful. And again, that Shift is also dependent on what we've got down here on our chains, our atoms, our segments, etc. So if I want to look at all of the chains here, I can just click and drag over these guys and select all chains associated with that. Now I've talked about how we can click through objects here. If we click anywhere in the matrix up here, we can swap between the viewing mode and the editing mode. Now the editing mode only has atom selections here, but in the editing mode in PyMOL version 2 that we're in, all of our single click options are exactly the same. So we can use the middle mouse button to move around, the right mouse button to zoom, left to rotate. But now when we make a click, instead of making a selection like we made previously, we make something called a pick. And you can make 4 picks. And if you've made 1 pick, you pick a single atom. If you make a second pick, you get your second atom, and you get a distance between those. So it's a nice, easy way of finding a distance. And again, we can click in space to remove those picks. If we make a third pick, we then get an angle between those atoms. And if we make a fourth pick, we get a dihedral. So if ever you're looking or are interested in measuring some angles or distances, then the editing mode is the easiest place to go to do that nice and quickly. In the editing mode, I'm not going to go into it with a lot of detail, but there's a bunch of other stuff you can do. For example, you can actually make edits to your protein. You can move it around, and you can make ridiculous changes to it, which are completely non-biological in nature. So again, what I'd do is I'd suggest that you just have a little bit of a play around with the viewing mode and with the editing mode, and see what these things do. So that was the viewing mode talked about there, and the editing mode. Yep, so I've done that. So let's also at any point you can type the word where are we? Rein, and that reinitializes your session, and we can then fetch our protein again, just so that it hasn't got those changes in there. Now when I fetch my protein, or when you've double clicked on a PDB file, you can see that here it opens up the object that I fetched, and I can click here and I can no longer see it, and I can activate and deactivate it. Now if I fetch another protein, let's say 2CHB, which is another copy of the same protein, you can see that now I've got 2 objects here, and I can activate and deactivate those 2 objects as I please. Also, you may have noticed that if I've got a selection down here and I click on a selection, I get this object, well, not an object here, I get this selection here called seller, which is the default selection within PyMOL. You can tell that it's a selection because it's in brackets. Now, as I click more things, you can see I'm adding to that selection, and I can turn that selection on and off. As I say, if I click in space, it removes that selection, but if I go back to it, it comes back. Let me actually just quickly say as sticks, so that we can see this a little better. Oh, right, so for example, here we are. I can select this glutamate here, and I can select the alanine next door. I can deselect, and then if I want to go back to that selection, it's still here. But if I deselect and reselect somewhere, now you can see it's written over my initial selection. So that initial selection of the glutamate and the alanine are gone, and I'm left with the histidine here. If I want to maintain a selection, what I need to do is rename it out of the temporary selection. And you can see over here now, I can renamed selection. So now we've got this renamed selection, and now if I click off and click somewhere new again, you can see that I've now brought back my temporary selection, and now I can swap between these 2 selections. Now, this is kind of important to do if you're looking to do some more advanced work with PyMOL, because then it means you can have a bunch of different things already saved as different selections. A word of warning though is that if you have a selection highlighted and you continue to click new things, you will be adding to those selections. So these selections, even after you've renamed it, they're not set in stone. They are, you can add and subtract from them. So once we have either an object in space or a selection, you can see that there's a bunch of little buttons next to it. These are the action, the show, hide, label, and color buttons, and inside each of those there's a menu associated with them. And you can do various things. For example, if you've got lost somewhere in your protein, but you have a named selection of some kind, you can orient upon that selection, and that brings us in. Let's see, I think, yes, I'll go into some more detail about all of these in a moment. But first, what I'll also do is, because we've explained this section, we've kind of explained this section, let me just explain at the bottom here. There are a bunch of buttons here at the bottom. Now, a lot of this is for something called state control, which we'll get into when we're talking about states. There is a little rock camera function, which is the down arrow. This can be helpful just so that you can appreciate the 3D nature of it, which sometimes is difficult. There's a full screen mode, and quite importantly, there is the S, which gives you your sequence view up at the top here. And you can scroll along here, and we can see all of our different our object here, 3CHB, and the chains. Well, actually, the first one here, the A, is the segment. Then you've got D, which is the chain, and then you've got the residue numbers, and of course the amino acid sequence down below. And if we add another object on, we add another line onto our sequence. Now, with all of the left click, middle clicking, etc., that we talked about earlier for picking the different atoms and selecting atoms, you can do the exact same thing on the sequence view. So, for example, I'm on residues here, so I can select those residues, and I can middle click on that selection. You can also, I haven't pointed this out, you can also middle click on the objects and the selections on the right here. So, for example, if I middle click on the named selection, I orient on my named selection here, and if I middle click, 2 seconds there, let's just make this selection here, and then there we are. Yeah. So you can see that we've not very well oriented around that selection, but there we are. And again, if I change here to chains and I click up here, I select the whole chain, etc. But navigating using the sequence view is very useful as well. At any point, if you ever get lost, which can happen kind of quite easily when you're moving things around, and you get fragments of bits and pieces, you can type the word orient, and that will bring you back to a view which shows everything. So let's dig into some of what these buttons here on the side do. So orient, let's get rid of that. Orient will always bring the view centered around your protein of interest. You can use center. I wouldn't, and origin. These two guys, these change the rotation, where the rotation of the camera occurs. So at the moment, when we rotate the camera, it always rotates around the center. But what you could do is have it rotate around here, and then things get a little bit crazy. So I wouldn't bother using those guys. I'd just use zoom and orient if you like. We don't need to talk about matrices. We can talk about the presets here. Now, you can do a lot of different kind of coloring when you're using PyMOL, and you can make all your chains different colors. You can add different coloring to your atoms of interest. But there are these presets, and it's kind of worth just having a look at some of these. So, for example, you can have this simple preset here. You can have a ball and stick preset, and the B factor putty. So this is showing you the temperature factors from the PDB file, and there's a bunch of different guys in there, like a technical one that's probably a little bit too detailed. But maybe we'll just go back to simple with no solvent. There we go. There is a find, so inside here you can find, well, mainly here polar contacts. You can also look at any contacts, but polar contacts is probably what you want, because this is how you can find hydrogen bonds. So for example, what we want to do here maybe is make a selection, and then while we're inside our selection we can go find polar contacts involving other atoms in the object. So this is, oh sorry, I've gone off script a bit here, haven't I? Polar contacts between chains. So now we can see, we can say as sticks. So now, for example, we can have a look at all of the different polar contacts that we have between our chains, such as these guys here. So that's how you can use the action buttons here to find different polar contacts. There's an alignment. So we can, for example, if we take we've got our two proteins here. If you're inside editing mode and you hold shift and middle click, you can move one object without moving the other objects. So for example, we can make sure that these two objects are not aligned, and we can say align this molecule to this one, and they align together. You can also see that when we make an alignment, it gives us a root mean squared deviation of the positions in angstroms here, so we can see that these overlap very, very well. I'm going to go through a few commands here to try and get back on script. This is state control. Sorry, I have gone completely off script. So I did want to talk about state control here, and then I started talking about the actions. But let's go back to looking at the state control. Here is a NMR structure. So we can tell that it's an NMR structure because when it comes in, it's got here a bunch of different states. You can see states 1 to 20, and using these state controls here, we can flick through these states one at a time, or we can press the play button in order to cycle through them quickly. Now, states in movies are kind of similar, and the movies use the states quite a lot. So what we can do is go into our movie panel here and look at our frame rates, and maybe move our frame rates down to 1 per second. And now we're moving a lot slower, so that it's a bit more sensible to look at. But basically we can move backwards and we can move forwards through the states, like such, and we go to the last state and we can go back to there. Okay, good. Let's go. So now I'm introducing some commands here, and maybe before I do this, should I show an as? Right, yeah. So we'll talk about this in a moment, but we can use some commands here to show sticks. This is an NMR structure, so we have a lot of hydrogens resolved here. We can use a command called remove hydrogen. I'd always advise doing this unless it's particularly important, because the hydrogens just add complexity. And then, for example, we can go back and look at our polar contacts within the selection. And then we can move through our states, and we can see maybe how these polar contacts are changing through our NMR structure, and maybe we can make some biologically relevant observation about that. If we have states, we can also use a command called split states. And what this does is it takes our 20 states that we had from our NMR structure, and it gives us all of them as individual objects. You can use join states to join all of these states back into our original composite, but that's not necessary to show that at the moment. And what we can also do is, I showed you before that you can align one structure to another, but what happens if you want to align all structures back to one structure? Well, again, we can go into our alignment here, and we can say align all to this. And of course it hasn't really changed because they were already aligned anyway, but it has actually performed the calculation for us and given us an RMSD there. Let's have a quick look at this. So here's another PDB. I've fetched this PDB, and if you've downloaded this PDB from the PDB website, you can see that this is maybe not what we were expecting here, because what we have is we've got what apparently looks like 4 proteins when we've downloaded it. Now that's because when you fetch a PDB, or if you download the native PDB file, you download and it's a X-ray crystallography file. You download something called the asymmetric unit, which means that even though these are 4 identical proteins, they're not so identical that if we overlapped them that they would be identical. There are minor differences between these proteins. However, for our interest, that's maybe too much information to have all 4 of these. So there's another thing that you can do when you're downloading a PDB file, and that's to download something called the biological unit. When you're looking at the PDB here and you want to download your files, you can download the biological assembly here, which is a more useful thing to download. But if you are interested in using the commands, which I suggest that you do, we can use the fetch function with our protein of interest here, and we can ask for the type equals PDB1. This is the biological unit. And if we do that, we just get one of the proteins. So that is then more useful. And let's also, for this example, fetch 2CHB. I've already shown this anyway, but we can do our alignment by saying align. There we are. And we can get rid of that. And you can see that we've got these 2 proteins. They are not particularly homologous. And I hope you can also see it's done a pretty bad job of aligning it here. You can see that we've got this little kind of beta sheet barrel here, and we've also got one here, and it's failed to align that. So I've used my standard align function that we find on our alignment menu here, but it's kind of failed, and this is why sometimes it's better to use commands rather than the GUI. So for example, if we type align 1QOH with 2CHB, that doesn't work very well. We can also use CE align, which is a center of mass based alignment. Now that one seems to have worked a bit better. You can see actually that these little like beta barrel sections that we have seem to be overlapping. And there's another one that you can use, which is called super. And if we do that, I think that's probably even better. And of course what we can do is we can check out these RMSDs that we have from making these to see how accurate our alignments are between the different techniques that we've used. So when you're aligning stuff and it doesn't seem to align very well with the action menus, then you can try typing some of these commands, and of course these are all found online as well. There are a bunch of other different things in the action menu. For example, you can rename stuff, you can delete things, you can make copies of, and you can extract parts if you have if you've made a selection. You can extract that selection to make that into a different object, which can be very, very useful, because that then allows, for example, I'll just show this. So if we select this oligosaccharide up here, let's actually try and get that whole segment there. Oh, okay. Well, we'll just click some of these guys. What we can do on our selection is we can extract object, and now that object that I've selected is an independent object. And the good thing about it being an independent object, if you're doing any design work or something like that, in the editing mode we can shift and middle click and we can start moving this thing independently, which might be useful for you. So I don't think I need to talk about the action menu anymore. There are various other things which are pretty obvious, adding and removing hydrogens and removing waters, etc. There's the S menu here. Let's clean this up a little. So inside the S menu, this is the show. There are two ways of showing things. There's show and there's show as, and you can see that show as gives you a second menu which is pretty much identical to show. Now what happens if we use show and we say show lines is that we've retained the original cartoon and we've added lines. So what show has done is it's made an additional representation on top of the first representation. If we go to show as and we go to sticks, for example, we've removed all representations and only shown that one representation. So by going through here, show as, we can say cartoons, or we can add to the cartoons. For example, to the cartoons I want to show only my side chains as sticks. And so now you can see that I've got no backbone sticks. I've just got cartoons for the backbone and sticks for the side chains. And that's a kind of nice low complexity but high information visualization for a protein. So yep, there we go. So you can also type this, and that is as simple as these commands here that I've got, as cartoon or as spheres, etc. Or, well, showing sticks when we've got the spheres probably won't be good, so because they'll be behind them. But there we are. So we can type show cartoon, show or as sticks, and you can see all of the different options here. Ribbon is a nice one to do if you're looking at a complicated show as ribbon, because this is really just tracking the carbon alpha backbone atoms here, which makes it a very nice simple view to look at. Let's go back to show as cartoon and stick on as side chains as sticks. What we can also do is just select the polymer. So what I'll do is I'll re-in and I will fetch to CHB. Now when we fetch it, you can see that we get all of the waters. We obviously get the oligosaccharides as well. But say we're only interested in the protein, you can just say select the polymer, and that then only selects the protein part. If you have a PDB that has nucleic acid in it, you can be more specific and say that you only, because the nucleic acid would also be a polymer, you can say select polymer protein, and that will only give you the protein, or select polymer nucleic acid, and that will only give you the nucleic acid. You can also just select organic, and that just gives us our oligosaccharides and small molecules and doesn't select our proteins or our waters. We can select inorganic, this will give us any salts that we have, and we can select water by selecting solvent. You can also choose not to select that particular thing. So for example, we can say select not the polymer, and that gives us everything. And we're saying not by having this exclamation mark here. And again, we can use this same selection nomenclature here to select or not select these various different components. Now, a lot of the next session that we're going to be doing, we're going to really be digging into this selection criteria here. But you can imagine that, for example, we want as cartoon, and then we can say we want to select not the polymer, and then in that selection we're going to show these as non-bonded atoms, and we can recreate back to our initial position there. So also within here you can, if you're interested, you can show the cell dimensions of the X-ray crystallography box. We can show the spheres, which I think I already put on. You can show a surface, which is always nice to look at, and then you can make these other options with disulfides and various things like that. We'll move on to the colouring. Hide is basically the same as show, except it's in reverse, right? It just hides the things that you've previously shown. And the labellings, PyMOL has a way of labelling things, but to be honest, if you're going to label anything, don't label it inside PyMOL, label it inside PowerPoint or Inkscape or whatever your favourite image manipulation program is, because the labels in PyMOL are a bit particular. So we'll just move straight on to the colouring here. Let's go back to as cartoon. Okay, so it kind of defaults, comes in as this kind of green. Let's have a look. So, and let's say as sticks actually. So you can see here that we've got all of our nitrogens in blue, all of our oxygens in red, all of our carbons in green, and our sulfurs here in yellow. Now, what we can do here is we can say colour by chain. This colours each of our individual chains a different colour. We can also have colour by element. Now what this does is this shows you which colour each of these different elements are going to be: carbon, hydrogen, nitrogen, oxygen, sulfur, etc. And you can see that down all these selections we always keep hydrogens, nitrogens, oxygens and sulfurs as the same colour, but what we're doing is we're changing the colour of the carbons. Now that's kind of important, because if we have if we fetch in 3CHB, sorry, I'm just going to use some commands here just to make my life easier. So now we have our two structures here, and of course what we can do is we can independently colour those two objects as we choose. When you're colouring by chain, a nice one that you can also use here is called the chain bow, and what this does is it colours in accordance with our PDB file from the beginning of the PDB file in blue to the end of the PDB file in red. So what we can also do is make a, let's say, let's colour everything into a nice grey colour. Beautiful. We can select a chain here, and now that we're in our chain, we can go into our chain bow. And now, of course, what we've done is we've coloured from N to C, blue to red, of one particular chain in our protein, and therefore we can make some kind of, again, biological decision on maybe where our N and our C termini are and how that fits in with the structure in general. So here you can also, if you're interested, you can colour our helices and our sheets. This would look better if we do as cartoon. So here you can see all of our sheets are yellow and all of our helices are red, all of our loops are in green. Let's have a look. And of course you can type all of these things as well. These are two very nice commands here. One of them is util cbc, and this is colour by chain, and here you can see that we add a color to all of our chains. But if we go to as sticks, you can see that we've also lost our the coloring of our atoms, and so therefore we can use color CNC. I thought this was color not carbon. I'm not really sure what it stands for, but here now we color all of our atoms back to their original colors. Sorry, going back to the secondary structure, we can also type this, so we can say color. We can choose a color such as fire brick or forest or density. You can find all of these strange color names by going into the reds here, and you can have raspberry and dark salmon and wheat if you want. But we can, for example, copy all of these into here, and we can add various different colors to various different parts as we choose. Now, so we've gone through these guys here and the selections down here, and I've talked a little bit then about how we can type in various different commands. So I just thought I'd like to show you how typing in these commands can make your life easy. For example, if you've saved a selection of some kind, or a bunch of commands in a text file, you can just copy and paste them in, and then you can get a nice looking protein structure to have a look at here without really having to have done much work. For example, you can change this to any particular PDB that you like. Let's try 1NQU, for example, and we can go and do the exact same thing. And there's a different protein. Almost all the proteins that I look at are pentamers, I'm afraid. But this is kind of the benefit to learning some of these commands, is that you can have a little text file, and when you open up a PDB of interest, you can just copy and paste these in. So next session, we're going to talk about how all of these different selections work with a lot of detail. You can see I've already been through a bunch of these today anyway. And using these selections, we can do some more powerful tricks with PyMOL than you can just in the GUI by itself. In the last 9 minutes, providing you are all still awake, I thought I'd go through some of the other features of the GUI, which just revolves around these menus up at the top here. The file menu, open, close, save. The only thing of particular interest for you here is to do this. If you want to export a PDB, you go to export molecule, and the selection here is everything that's enabled, so everything that we can see. Yes, we want to save everything that we want to see. And then you get some options here if you want to save PDB files, PQR files, MOL2 files, CIF files, etc. So you get to choose which kind of file extension you want to save with. If you had a file save session, let's just do this. Actually, I won't bother actually saving it. When you save a session file, you literally save it in the exact position that it's in now. So if you save a session file of this that we have, and then you reopen it, it will be exactly like this, with the white background, the colored chains, the small molecules in black, etc. So a session file really restores the exact environment that you're in. We can talk about log files and scripts in the next session. There is the editing menu, which really doesn't have a lot. There's some undos. Undo in PyMOL isn't very functional, and there's a lot of things that you can do which cannot be undone. And therefore, it's a good idea to use this save session quite regularly in order to make sure that the things that you've done you can go back to. There's a build menu. Let's just see what I want to talk about in here. We're going to go and talk about building in another session, so I won't go into this with much detail at all right now. The movie, I've talked about the frame rate. We've got a whole session on movies where we'll talk about how you can make use the GUI to make some very basic movies. Let me just think, and there's probably not a lot more in there that we're going to be very interested in either. Display. Here you can change your background using the GUI, so at the moment we're on white, and we've got some other options here. There's the color space. This is really for printing things that we don't really need to worry about. Stereo mode we don't need. Orthoscopic view, this can be very useful. So at the moment our view is kind of three-dimensional. There's perspective in our view, whereas if you go into the orthoscopic view, it removes all the perspective from our view. Now this isn't particularly obvious here. Let's just let's copy this to a new object, go into our editing mode, move our copy here. Now, oops. Now, for example, in orthoscopic view, we're looking down the center of these guys, whereas if we were outside of orthoscopic view, you can see that now they've been tilted by the perspective because one's on the left and one's on the right, etc. Can be useful to know about that. Another kind of useful thing to look at is this guy called roving detail. And what this does is wherever you've middle clicked, it adds extra structural information to the local area. So this can be nice for having a look around your protein and getting extra information about that local environment without having to do a lot of the stuff yourself. We better turn that off. In the settings, there's all sorts of stuff, like you can add transparency to your cartoons if you want to. I don't know if that's going to be something of interest to people. The main one that people would use this for is that they would say that we want to show a surface, and then they go into settings, transparency, surface 50%, and then we can see through our surface and see what's underneath. That's a typical thing that people like. There's a bunch of different rendering effects you can put onto here, different ways of displaying your cartoons and your ribbons. And that's about everything for that one. Let's refetch to CHB, and let's remove not polymer and show as sticks. And let's just have a look at something over here. There's this wizard. Inside the wizard option here you have this measurement guy, and this opens a box down here. Here you can see on this first button here that I can measure distances, angles, dihedrals, etc. So these are all the different measurements that you could do by using the edit menu. However, when we have it open on the wizard, we get this little box here which says click on your first atom. So what we can do is click on one atom, click on a second atom, and we can get a measurement. Now, unlike the editing mode, these are permanent, and they're also added as options up here, little selections as such. And we can continue to just manually make measurements as we choose inside the environment here. And it's the same with the angles, except of course you're going to choose 3 different positions there, and we can show our angles there. Also within the wizard there's this mutagenesis function for proteins, for example. So here I can click on this histidine, which I don't want to be a histidine. So instead of it being on no mutation, we can say, well, actually I want it to be an asparagine. and then you can see it's modeled in white, some options there. I can flick through the different rotamers of the asparagine by clicking through these different states, but typically the first state that it gives you is the state which fits best, and then you can just say apply, and that means that mutation has been made. So that's if you want to make some mutations. That's probably everything I want to cover there. There's some plugins here. For example, the applied Poisson-Boltzmann solvator, which can show you the electrostatics of a protein of interest, and some more complicated things as well. And some help pages as well, which can take you to the wiki, to the command reference, and various other things like that. There's also, in the last minute, another box up here with some other options in. The biggest thing that we want to talk about here is this is a builder option, which gives you this window here where you can build different proteins or chemical moieties. So you can actually build stuff in 3 dimensions here in a similar way that you would in ChemDraw or something like that. Right, sorry, whistle stop tour there. Anyone have any questions? If there's no questions, then I think we're done, and I can see you all next time.